Hello, in this video we're going to look very closely at the acceleration caused by gravity. Now you'll notice here it says near sea level on Earth. So what that implies is that the acceleration caused by gravity changes with height. So what do we mean then by near sea level? When we're talking about near sea level, we mean within the normal range of heights that humans experience. So we could say from sea level or slightly below sea level, so plus or minus sea level, all the way up to the tallest buildings. So what that means is near sea level means in the normal range of experience that all of us will have in our day-to-day lives. And even beyond our day-to-day lives. Even flying in an airplane up to 37,000 feet above sea level, the acceleration caused by gravity is very, very close. It changes very, very little bit from what it is near sea level. Well, what is that number? That number is 9.80665 meters per second squared. And if we were to look at the decimal places that we know for this, well, here we have the ones place. Here we have the tenths. Here we have the hundredths. Here we have the thousandths. Here we have the 10,000ths. And lastly, here we have the 100,000ths. So if we were to take this number and round it to the nearest 10,000th, well, that would be to this place. The 5 would cause it to round up, so that would be the number 9.807, 67. 9.8067. And if we rounded it to the nearest thousandth, that would be this place. Well, that would give us 9.807. And if we rounded it to the nearest hundredth, well, that would be 9.81. And if we rounded it to the nearest tenth, that would be 9.8. And if we rounded it to the nearest 1, it would be 10. Now, what we then can say about all of these values is that this value and 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 this value, they all represent the same number. They represent the same number to a different level of precision. So all of those numbers represent the same thing, and we know them different levels of precision. If we look at this one up here, we would say that there are, the first one, we would say there are 6 significant digits. And here we would say there are 5 significant digits, and here there are 4, and here there are 3, and here there are 2, and here we would say there is 1 significant digit. And really then the right way to express it is 1 times 10 to the 1. And when we have a number like this, we use it to make estimates. When we only have 1 digit, we use it to make estimates. So that's a little bit of a discussion about the value of gravity, where we can use it, and the different values of it that we could see. So if we want an estimate, we would use the number 10. But if we want something that is precise, we would use 9.80665. For a precise calculation. And so this number 9.80665 we would use when we use our calculators. If we're doing things in our heads, well, we would use that number 10. So I'm going to show you a feature where we can store this number in our calculator so we don't have to remember it. So we go to our graphing calculators and we type in that number 9.80665. And the calculator has the ability to store a whole bunch of different numbers. And there is a store button to the left of the 1 and the 4, STO, and we hit that, it will make an arrow. And so on this calculator screen, it's saying, take that number 9.80665 and store it as a variable. Well, that variable we want to use is G for gravity. And the way we access G is to use the alpha key, and the tangent key has a little G above it. So we'll take that number and store it as G, and we hit enter. Now when we clear the screen, whenever we hit alpha G, alpha tan, which is G, and hit enter, it will give us that number. So let's suppose we wanted to know 25.7 times that number G, alpha G, and it will give us the unrounded number. And it's actually giving it to us here in scientific notation. And we could change it into a regular number by pressing mode, and we can use normal. Not sure why it's not letting me change it just to normal. Now let's try that. There we go. I had hit enter. And we get out of this by hitting second mode, which is quit. And now we do 25.7 times alpha G. We hit enter, and it gives us the number 252.030905. But you also see how we could switch our numbers into scientific notation if we would like. So that is G, the acceleration caused by gravity, and we will usually see it written as a lowercase g. So lowercase g equals 9.80665, the precise value. We can store it in our calculator. We can use it for just about anywhere that any human being besides an astronaut would go on the Earth, and we can use that number there.